Hi, and welcome back to the Business Career College video series. This video we're going to shift gears a little bit and we're going to work with Excel. We're going to learn how to do a little bit of time value of money calculations using Excel. I do like the financial calculator. I'm a big fan of the financial calculator, but there are some calculations where it's just easier to use Excel. And this is especially true when you have a bunch of variables that might be moving targets that might you want to play around with things a little bit, maybe run a little bit of an experiment or something like that. Excel can be quite useful this way. So to give an example of where you might use Excel, let's say that we have a client here who happens to be purchasing an annuity. And this is a good example of the kind of calculation that's a little bit simpler with Excel than it might be with a financial calculator, because we have some moving targets here. So with this annuity, we have to make some assumptions, or we have to be able to use the basic time value of money functionality that we're accustomed to. So let's say that this client, we have to determine their starting age. This is going to be part of our calculation. And we have to determine their mortality. So just like I do when I use my financial calculator, I'm going to walk through things a little bit here, and then we're going to actually do some math. So we say, what if the client buys at a given age, and what if the client dies at a given age? And then we need a discount rate. Now, this might be one of the things that we end up solving for. So let's come back to this discount rate in a moment here. And so I'm just going to merge some cells across the top here so that we can get this to work for us here. Let's clean things up a bit. And we need to know then what the principal involved is. How much is this client putting in? And is there going to be any death benefit? Is it going to be a life straight annuity with no death benefit paid? Or is there some amount that's left behind at death here that would make this a little bit different? And we want to look at what the actual annuity payment is going to be. So what's the annuity benefit? We'll call it, to be clear here. So what's the annuity benefit? And assuming that's a monthly benefit and so forth. So where do we go from here? Well, let's just go and fill in our variables. And let's say that the client's question, or the question we're trying to address here, is what is the sort of discount rate, or the opportunity cost, if you want to look at it that way, or what's the rate of return if I buy this particular annuity. So let's say the client is looking at purchasing annuity at age 72. And we look at mortality. Let's say, for the sake of argument, the client has mortality at age 85. So we say, what if the client dies at that particular age? We're going to come back to discount rate. We're going to solve for that here in a moment. And this client, let's say, has $100,000, just to keep it easy here. And I always like to do this in currency format. Sorry. And let's say that we're doing this with no death benefit. And so we just have everything in currency format here, no decimal places. And if you just hit the dollar sign in Excel, it brings it into accounting format. Accounting format doesn't paste as cleanly into other documents. It's appropriate if you're doing nothing but financial statements, but that's not what we're doing here. And let's say, for the sake of argument, that the insurer involved is willing to pay a benefit of $640 per month. So once we've figured out what variable we're trying to solve for, we're just going to go to that cell, and it's just a formula now with Excel. So some of you will be familiar with some of this, and some of you won't. So I'm going to try and keep it basic here. We do equal sign, and that tells Excel now that I'm going to use a formula. So up at the top here, we're going to use the formula bar, and Excel will do any of the calculations that we're accustomed to with a financial calculator. So in this particular case, I want to use rate, And rate is the same as on your financial calculator, IY or IYR. And I'll show you in a second that it's a little bit different than how your financial calculator might do it, unless you're sort of a little more old school with the calculator, in which case Excel will look very familiar to you. So you'll see what happens when you type this out. Excel sort of helps me to cheat a little bit. It says, rate, what does this tie into? So NPER, that's your number of periods. You can click on this actually to get a little pop-up that shows you what that refers to, although it's a little bit tricky within the video to do that here. And so we do our number of periods is going to be based on mortality minus age. So we're going to have 13 years, but Excel sort of assumes that everything, or we know payments are being made monthly, so Excel is going to do everything monthly. So I also have to put in some brackets here and multiply that by 12. And basically now Excel is going to take what's in the 85 spot, cell B3, and what's in the age spot, cell B2. It's going to subtract those out and multiply by 12. So now you're going to have 13 times 12, or 156 payments being made. And now Excel says, okay, now tell me which one is the payment cell. So I can go down here and click on payment. And that is going to be money coming to you. So we'll leave that as a positive. And then future value, so sorry, present value. So now we have to tell the calculator what we want for present value. Now, just like you'd have to do with your financial calculator, you have to remember to do your positives and negatives. And this is money going away from the client, so I will do that as a negative. And then Excel says, now tell me what the future value is. Now we've assumed no death benefit here, so you would leave that as no death benefit. The next cell is optional. That's what it means, what's in those hard brackets. Whether you want to do begin or end. Annuities are normally paid at the end of a period, so we will put it in as end. And then you can put in a guess. You certainly don't need to do this with Excel because, or with simple time value of money. Sometimes with more complex calculations, if you put in a guess, it helps Excel to sort of zero in on what you're trying to accomplish, but we don't need that guess here. So now we have all of our variables. Now Excel is going to solve this right now for a monthly rate, and I know that I probably want to see an annual rate. So to close it all out here, I'm going to just multiply it by 12, and now Excel is going to solve for a monthly rate. So I know this is not a great rate of return, okay? And actually, if you solve this in your financial calculator, you get the same rate. I would express this as a percentage, and I would just give a couple decimal places here. So I say, okay, that's not outstanding. But now I can easily play around with the variables. I say, so client, if you live 13 years, you're going to get an income of $640 a year for that period. But what if you live a little bit longer? So now we can play around with our variables here. So let's say the client lives to age 86, for example. So now the rate of return gets a little better. And what if they live to age 87? And now the rate of return gets a little bit better than that even. So you can sort of play around with these variables to your heart's content. And what you might even do here is you say, okay, client, we're going to show a bunch of different possible outcomes here. So let's start at age 80 and let's see a bunch of what if scenarios. What if you die at given ages? So we're just going to run this all the way across. So do one more year here. And then we're going to do, all right, what if you continue to die at increasingly older years? So this is fairly straightforward. Just take the previous cell, add 1 to it, and we run that all the way across. And we're going to just use the same amount of principal all the way through. You don't even have to necessarily do that way. What you could actually do here is you could use Excel's function in which it's going to always refer to the same number here. So I might say, Excel, every time we get to the principal portion, which is B5, I want you to refer to the same amount. So we're just going to hit F4. It puts in those dollar signs, which means now it's going to constantly refer to cell B5 no matter where I end up on the page. And then I'm going to do the same thing for the annuity benefit. So the annuity benefit is also going to constantly refer to the same place. I just hit F4 and it puts in those dollar signs. If I hit it again, you'll see then it'll make a constant reference to row 6 column, but row 6, but it'll switch columns as it moves over. Or you can hit it again, you can cycle through. I want it to constantly refer to the same place. So now I don't have to copy all of those variables across. So now Excel says, okay, what if we end up with those variables all the way across and I have messed something up. Sorry about that. I see what I did. I messed up the annuity benefit. I grabbed the wrong cell here. And we should go back here. That's exactly, you can see what happens when you make that mistake. So we're going to pop back and we're going to hit the F4 here as well. Sorry about that. And now we're going to copy that all the way across and that will fix. So now you can use this to sort of build these what if scenarios, and instead of having to do what we have on the page here, 10 different time value of money calculations, Excel does all 10 of those calculations for us. And you could use this to demonstrate rate of return this way, just like so. So fairly easy to do it that way. Now let's say you looked at another insurer and their annuity paid $670 a month. So now you've got a larger benefit. Or maybe you choose a guaranteed period. You say, what if we had a guarantee here? And maybe you've got a 5-year guarantee, for example. So what you could do is you could put in your various guarantees. You might manually enter them, or if you know how they're calculated, you might otherwise put them in. So let's say, for the sake of argument, you purchase this annuity, and you know if you die in year 1, it has a $50,000 benefit and a $40,000 benefit in year 2, and so on. So let's say that that happens to be how this annuity pays out, and maybe now it's a little smaller annuity for us. And now it's going to be, let's say, a 0 benefit for each of those remaining years. So now I can go in and I can get Excel to get rid of that $sign reference. So now I want to find the cell. I can see that it's cell 6 here. So I flip over to cell B6 and I say, actually, Excel, get rid of that. So now it's going to refer constantly to the cell below it. Just have to copy that formula all the way across. And now you can see here that Excel is calculating the rate of return here if you invested that money, died, and left behind that much of a lump sum benefit. And we can see it's a constant reference, or sorry, it's not a constant reference anymore. It's referring to cell C6 now. So it's the same type of thing you might do with any number of calculations. I hope that that helps to see how the rate calculation works. And I'm just going to show you briefly here that we could then play around with any of those variables. So let's say that we know, and this would be a little bit artificial, maybe with a term certain annuity, you know you're getting a rate of 2.25% on that term certain annuity, so it's going to overwrite everything else we've done here. And you know that you need a benefit of, let's say, $350. So potentially what you could do here is, knowing now that you're going to get that 2.25%, just delete everything over here, we don't need that anymore. Knowing you're going to get 2.25% and knowing you need a benefit of $350, what you might say here, and I understand this is a little bit easier calculation, but just to show how this would be done, you could similarly say, how much principal do I need at 2.25% in order to provide this amount of income? And we're not going to deal with mortality now, we're going to deal with term. So let's say that we happen to have a 10-year term annuity that we're buying, and now we could figure out how much principal we need to buy that. So you just do equals, and now we're going to solve for a present value. And you can see again that Excel will let me calculate present value. So again, you're going to do what's the rate here, And Excel is going to see monthly amounts going in, so you want to make sure you divide that rate by 12. The number of periods, we're going to do something similar to what we did before. We're going to take 82 minus 72, that's 10 years, and we know we have a payment every month, so we better do that monthly, and then we go on to the next, which is our payment. And future value is going to be 0 here. We're not going to have anything out at the end. And now we can solve for the present value. That's going to show up as a negative number. And I'll show you that. So if you didn't want it to show up as a negative, maybe for sake of displaying to a client or whatever the case is, you can just put a negative in front of that. And it'll show up as a positive number now. That's good. So in order to buy that annuity at that rate, paying for 10 years, you would need $37,500. And we can solve for future value the same way. So again, it's just a matter of telling Excel, hey Excel, I want to solve for future value, and you can see it does the same things. It just tells you. And you can solve for number of periods, your time frame. You can solve for payment. So you would just do equals NPER or equals payment. And now you just build it out like so. If you just sort of let Excel lead you along, it actually becomes a fairly easy thing to do. So I hope that that's helpful in terms of doing time value of money calculations with Excel. It's a good tool when you have this sort of different set of variables you want to play around with, and especially if you're dealing with a multi-year calculation like we did initially with the annuity, it becomes quite a great tool. I do strongly encourage you to play around with Excel and try and get comfortable with doing this for time value of money calculations. I find it's very common that students, when they learn this, they come back and say, I can't believe that I never knew this. I can't believe that I didn't have this tool available all along. So I hope you enjoy your continued studies. Thank you very kindly.